Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics Class 12th. The chapter that we're dealing with currently is three-dimensional geometry. This is the beginning of the chapter, not dealing with, but this is three-dimensional geometry. We'll be discussing exercise 11.1 today. This is the beginning of the chapter. Exercise 11.1 is a pretty simple exercise based on something called direction cosines, direction ratios, nothing much is there. Then the next two exercises are based on equation of a line, equation of a plane, and then this is a miscellaneous exercise. There are four simple exercises in this chapter. This one is a relatively smaller exercise. Let's discuss the questions, and along with the questions we'll see the concepts involved over here. The first question says, if a line makes angles 90 degree, 135 degree, 45 degree with x, y and z axis respectively, find its direction cosines. Now, what are direction cosines? Basically, if you have, let us call this x-axis, this is the y-axis, this is the z-axis, and there is a line making some angle alpha with x-axis, some angle beta with y-axis, and some angle gamma with z-axis. In that case, you define something called direction cosines by L, M, N, which are cos alpha, cos beta, cos gamma. These are the direction cosines of this particular line. We could have had a line parallel to this, and a line parallel to this will have same direction cosines. For example, if you are given a line like this, you will transfer this line passing through the origin, and then you can say, okay, the angles are alpha, beta, gamma, and therefore the direction cosines are cos alpha, cos beta and cos gamma, which are also represented by L, M and N. There is one important thing about L, M, N. What is that? L square plus M square plus N square is equal to 1. This is one important property of direction cosines. That's what you can note, right? What else? Anything else? No. Just that, and we are good to go to solve this question. If a line makes angles 90 degree, 135 degree, 45 degree with the x, y, z axis, so you can say L equals cos 90 degree. What is that? 0. M is equal to cos 135 degree, which is minus 1 by square root of 2. N is equal to cos 45 degree, which is 1 upon root 2. So therefore, direction cosines can be written as 0 minus 1 by root 2, 1 by root 2. That's my required answer for this question number 1, as you can see over here. For question number 2, it is, the person says that find the direction cosines of a line which makes equal angles with the coordinate axis. Equal angles. What does equal angle imply? Alpha will be equal to beta will be equal to gamma. That's what you can note, right? Equal angles implies alpha will be equal to beta will be equal to gamma. L, which is cos alpha, M is cos beta, N is cos gamma, right? And one important property which we already know is L square plus M square plus N square is equal to 1. If alpha is equal to beta is equal to gamma, you can note that these three things will be exactly same. Therefore, this is L square, this also becomes L square, this also becomes L square. This tells me 3L square will be equal to 1, or L square will be equal to 1 by 3. L will be equal to square root of 1 upon 3 with a plus or minus, which is plus or minus 1 upon square root of 3. And therefore, direction cosines can be written as L, M, N. M and N are exactly same as L. So this is this. Why are there two signs plus or minus? Please observe, plus or minus imply that the line makes equal angles with the three axes, this and this. If the angles are equal, then in the opposite direction also you can have that same line making equal angles with the coordinate axis, right? In that sense, and therefore we have this as the direction cosines. Question number 3 says, if a line has a direction ratios this, then what are its direction cosines? Now, direction ratios, two direction cosines can be found easily by dividing with the magnitude. What do you mean by that? that if direction ratios are nothing but basically proportional to direction cosines. So if you have direction ratios as A, B, C, if you have direction ratios as A, B and C, then what you can do is you can find direction cosines by simply dividing with under root of A square plus B square plus C square. B upon under root of A square plus B square plus C square, comma C upon under root of A square plus B square plus C square. These will be the direction cosines for these direction ratios. You can see the sum of squares should be equal to 1. You can see A square, B square, C square upon A square plus B square plus C square is equal to 1. That's the important thing about direction cosines, right? Okay, so it is given that a given line has direction ratios given. Direction ratios as minus 18, comma 12, comma minus 4. Find the sum of squares and under root first. Okay, therefore minus 18 square plus 12 square plus minus 4 squared under root, this will be equal to what? Let's find that first. So what do we have? This is 324, this is 144 and this here is 16 in the under root. Where does that take me? This is equal to 484 under root, which is equal to 22. Now this is 22, therefore direction cosines will be minus 18 upon 22, comma 12 over 22, comma minus 4 upon 22, or you can cancel a factor of 2 in the numerator and denominator, minus 9 upon 11, comma 6 upon 11, minus 2 upon 11. That's my required answer for this, right? Direction cosines will be this for this particular third question, as you can see over here. Question number 4 says, show that the points this are collinear. How can you show that these 3 points are collinear? Now direction cosines, direction ratios are similar to kind of idea of slope that you have in 2-dimensional geometry. When we say that these 3 points have to be proven to be collinear, one of the simplest approach is to find the direction ratios of first 2 points and the next 2 points, right? For example, if you have A, B, C. A is x1, x1, y1, z1. y1, z1. This is x2, y2, z2. This is x3, y3, z3. If you have this, then can you note that direction ratios of AB will be what? First of all, direction ratios of AB will be simply x2 minus x1, y2 minus y1, z2 minus z1. And similarly, if I want, I can find the direction ratios of BC. If direction ratios of AB and BC are exactly same and there is a common point B, right? If direction ratios are exactly same, then the lines will be parallel. And if there is a common point, between them, then you can surely say that parallel and a common point implies they will be exactly same, right? That's what we'll be checking over here. Let the points be A, 2, 3, 4, B, minus 1, minus 2, 1, C, 5, 8, 7. And now let us find the direction ratios of AB. What is that? This is minus 3, minus 5, minus 3. Those will be the direction ratios of AB. x2 minus x1, y2 minus y1, z2 minus z1. What about direction ratios of BC? Can you please note that 5 plus 1 will be 6, 8 plus 2 will become 10, and 7 minus 1 will become 6. This is what you have. And if you note this carefully, this and this, if you note the ratios, 6 upon minus 3, 10 upon minus 5, 6 upon minus 3. All of these ratios are minus 2. Yes. Since this is equal to this, therefore DRs are proportional. DRs being proportional tells me that direction ratios being proportional tells me that AB is parallel to BC and there is a point common in between. B is common. Therefore, ABC will be collinear. That's what you note from here. Therefore, ABC will be collinear. Hence proved. That's a complete proof of this question. Question number 5 says, find the direction cosines of the sides of the triangle whose vertices are this. The direction cosines are not difficult. x2 minus x1, comma, y2 minus y1, comma, z2 minus z1 are the direction ratios. And from the direction ratios, you can find the direction cosines easily, right? Let me first mark the triangle with vertices A, B and C as this. 3, 5, minus 4, minus 1, 1, 2, minus 5, minus 5, minus 2. If you are given these three vertices, then the direction ratios for AB, BC and CA can be found easily first of all, and then on the basis of that I can easily get the direction cosines. So let's focus on AB first of all. For AB, the direction ratios will be minus 1, minus 3, which will be minus 4, 1, minus 5, which will be again minus 4, 2 plus 4 will become 6. This. Okay, and the magnitude has to be found by dividing. This is 4 square, which is actually, let me write 16 only directly over here. Magnitude of AB, that is what is important. What is that? 16 plus 16 plus 36. That is equal to 68 under root, which is 2 root 17. This is what you get, right? 68 is 4 times 17. Square root of 4 will be 2. 2 comes out, 2 root 17. Therefore, direction cosines of AB will be minus 4 upon this will become minus 2 upon root 17. This will again become minus 2 upon root 17, comma 3 upon root 17. That's my answer for first part, AB. Let's take a look at the next one, BC. So for BC, the direction ratios will be this minus this, which is minus 4 first, minus 6 then, and minus 4 next. If you see, the magnitude is exactly same, therefore the magnitude of BC will be same, which is 2 root 17. And on the basis of this, therefore direction cosines of BC will be minus 4 upon this, which is minus 2 upon root 17, comma minus 6 upon this, which is minus 3 upon root 17, comma minus 2 upon root 17. These will be the direction cosines of BC. For CA, next let's take a look at CA. Direction ratios will be what? CA, this minus this, which will give me 8, 5 plus this becomes 10. Then you have minus 4 and minus of minus 2 will become minus 2. This is what you are having. Magnitude of CA. Let us take a look at magnitude of CA. What does that tell me? This is 8 square 64, 104. That's 168. If you can please observe that. This is under root of 168. Is that okay? Yes. Let us check this again. 3 and this, 5 and 5 and this. Yes, this is what you get. Under root of 168, and 168 can be factorized into, in terms of 8, 821. 8 times 21 is what you have, or you can write it as 2 under root of 42 only. Leave it at this stage. Therefore, direction cosines of CA will be what? 8 upon this, which is 4 upon square root of 42, comma 5 upon square root of 42, comma minus 1 upon square root of 42. That's the answer. This and this form the complete answer for this, that the direction cosines of the sides of triangles vertices are this and this. And one important thing over here is, if you've taken AB, BC and CA, you could have taken another direction as well. In case direction changes, the answer will correspondingly change. But this is the general form that you follow, that first, second, second, third and third, first. That's what the notation generally that we follow. Okay, so that's all in this particular question. With this, we come to the conclusion of this particular exercise, exercise number 11.1 from the chapter 3-dimensional geometry of class 12th. That's all for today. We'll meet in the next session. Till then, all the best.